Okay, so we can prove triangles are similar by either angle-angle similarity or side-angle-side similarity or side-side-side similar. So in this case, we know we have two angles that are congruent from vertical angles, and we're just checking to see if these sides are proportional. So that's, in the case of similarity, they're not necessarily congruent, but they're proportional. So what we want to do is compare the smallest side of this triangle, the 39, to the smallest side of this triangle, which is 16, and to the bigger side, this one is 40, to the smaller side is 16. And already looking at it as we were doing that, it's like, oh, those are not the same. So this is not going to be, if they were the same, it'd be side angle side similarity, but these guys are not similar. Bummer for them. Let's try the next guy. So if this guy were to be proven similar, we're given stuff about the sides, so let's make proportions with the sides. We'll do the smallest to the smallest, 48 to 8. Does that equal the middle to the middle, so 72 to 12, and then 84 to 14, comparing those longest hypotenuses. So if we simplify all these, that's 6 equals 6 equals 6. Heck yeah, these are similar. So they are in fact similar, and we'll write our similarity statement. Looks like C is the same as F, and the right angle, B is G, and then A is the same as H. And so there you go. We do it again. So we're looking, we have another pair of vertical angles congruent, and let's see if these guys make it. We'll compare the smaller side, that 8, to the smaller side, 28, and we wonder if that equals 14 to 49. That's, is that right? Oh, that's okay. So this is divided by 4, that's 2 over 7, divided by 7, that's 2 over 7. Yeah, that checks out. So then you make your similarity statement. The V on this triangle is like the V on that triangle, and the U on this one is like the, comes from the shorter side, right? So the, what am I doing? So this is the shorter, so it's like the L. There we go. And then the T is like the M. There we go. And we do it again. So let's see. Oh, this one's the nicest. The angles are the same, therefore the third angle must be the same. My geometry book called this the no choice theorem. But they're definitely similar by angle-angle similarity. Oh, and I should have said that this one was similar by side, angle, side, similar, and this one was similar by side, 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 similar. And then you just make your similarity statement. So J is like, let's see, scribbled all over this thing. J on this one is like T on that one. K on this one with the 2 dashes is like U on that one. And L with the 3 dashes is like V on that one. Check. Do it again. This guy here, we know that these are vertical, and are these different angles here? Yeah, this one's marked with 1, and this is marked with 2, and this is marked with 3. So I don't know, I have one angle for sure that's congruent for both the triangles, but I don't know anything about these angles. They're not, if one of these had the same mark, if this was 1 mark and 1 mark, then they would be similar, and I could say angle-angle similar. But for all I know, they're all different, and so these are not necessarily similar. We don't know anything. So we do it again. Oh, and now we're into these, and I'll make another video of those. Okay.